Good day, folks. Today I want to review one of the questions on assignment number 3. In this particular question, we are looking at two ice cream making models. First one's called Smoothie. It has an initial cost of $15,000, service life of 12 years, annual profit of $4,200, an annual operating cost of $1,200, and at the end of 12 years, the unit will have a salvage value of $2,250. Conversely, the creamy unit will have an initial cost of $36,000. Will also last 12 years. The annual profit from that unit will be $10,800. Our annual operating costs will be $3,520, and our salvage value at the end of 12 years for this creamy unit is $5,000. So, as I do with most problems in this course, I always draw a cash flow diagram. So you can see over here on the right, get my left and right mixed up. On the right, I have drawn a cash flow diagram for the smoothie. I have my initial cost, my annual revenues, and for each of the 12 years, my annual costs for each of the 12 years, $1,200 in this particular case, and also I see at the end of my cash flow diagram I put in the salvage value, all right, and it's 12 years. Similarly, I've done the same thing for this creamy unit. $36,000 is our initial cost. We have our $10,800 revenue, our $3,520 of operating costs, and my salvage value of $5,000 at the end. And again, as 12 years for this particular unit. The only unknown in this particular problem is the interest rate. We do not know, we're not given the interest rate anywhere in this question, okay? So it takes a little bit of mathematics and eventually interpolation to determine that final interest rate. So where do we start? Well, let's start by calculating the present worth for each of the cash flow diagrams. And we'll substitute in the factor notations for the unknowns that we have in this particular problem. So if we look at the smoothie one here, and the solutions here on the left, we can see that for present worth analysis, we have our negative $15,000 initial cost, plus we have annual revenues and annual costs, so we can subtract those directly, but we want to convert them to a present value, so we want to find P given A to convert these annuities into a present value. So P given A for I, we don't know I, and N is 12 years. Finally, we have our salvage value, which is a future value, and we can convert that to a present amount by using the PF factor. So we find P given F for a particular interest rate for 12 years. And like I said, we don't know the interest rate for either of these calculations. So we can just do a little bit of math here and simplify the formula. So we have negative 15,000 plus 3,000 times our P given A for an unknown interest rate for 12 years, plus our 2250 multiplied by our P given F factor for whatever same interest rate for 12 years. And we can keep this formula in our pocket for a minute. So to repeat the same process for the creamy machine, we have our initial cost of negative $36,000. We have our annual revenue and annual operating costs. Again, both of these are annuities, and we can convert them to a present value using the PA factor. And remember, you read this like to determine P given A for a particular interest rate for N years. And finally, we have our salvage value of $5,000, and we can convert that to a present amount using our PF factor, to find P given F for a particular interest rate and N years. And we can simplify that formula down to this equation. Negative 36,000 plus 7280 P given A, I12, plus 5,000 P given F, I12. Now the problem asks us that we need to determine the interest rate to make these two alternatives equivalent. So what we do is we have two formulas with two unknowns. So we make those two formulas equal to each other. So we let the present worth of the smoothie equal the present worth of the creamy. And through some mathematical manipulation, we can factor out some terms and simplify the formula such that we end up with this following formula. Where 21,000 equals 4280, P given A, I12, plus 2750, P given F, I12. You notice each of the formulas have a P given A factor and a P given F factor, so we can just factor those out directly. So now we have one equation with two unknowns. And what do we do then? Well, it becomes an exercise in trial and error. In this particular problem, you have to pick an interest rate, substitute in the associated factors for that particular interest rate, and see what you get. See if you're looking for a number near $21,000, okay, for a given interest rate. So as I mentioned, is trial and trial and error with interest rates is something we're going to be using throughout this course, so it's better to get used to it now. So let's pick an interest rate, and in this particular solution, we picked an interest rate of 15. You could start at 10. When you pick your interest rate, you calculate your numbers, and you will see which way you need to go with your interest rate for your next calculation. So at 15%, we go to our 15% table, and we look up the two factors. So this is our 15% table. Our P given F factor is 0.18691. Our P given A factor is 5.4206. And you take those two values and plug them back into your formula. And once you do that, you calculate that the left-hand side, that's what LHS stands for in this particular solution, turns out to be 23,714. We're looking for 21,000. Okay, so we're above our intended target. So we need to select another interest rate. Let's try 20%. In this particular case, we try 20%. We go to the 20% table. We pick out our PF factor and pick out our PA factor for 12 years. And we plug them into the formula. And when we plug those into this formula, we get a left-hand side of 19,308. Again, we're looking for 21,000. Okay, so we have at 20%, 19,308. At 15%, 23,714. At what percent we need 21,000? We've surrounded the answer we're looking for. We've got a number above and below the number we're looking for. So we can use linear interpolation at this point to determine the exact interest rate. So you take these 3 points, 20% and that 19,000 there, 15% and the 23,000 number, and our unknown percentage, and 21,000. And you plug them into the linear interpolation formula, which is on your formula sheet, and you do the calculation, and it turns out that the exact interest rate that make these two alternatives equivalent is 18.1%. All right, that's the solution. Thanks.